Welcome to all of you. Today we are going to start a lesson in mathematics on circles, explaining its importance and also different properties of circles which are very much useful in our daily life. First of all, we will let us know the importance of circles. To know it, you can see the world around us. If you see the world around us, if you go to a sawmill, you have a wheel which cuts the wood and many other materials with the help of a belt, metallic belt. You have seen, which can cut the wood. There you will understand how the wheel works. You can think of motorcycle, bus, cars, anything. So many circular objects like wheels are very much helpful in our dynamic world. So this clearly reflects how circle is very important and how the subject is very important for us to learn. So if you know the properties of circles, then we will be able to design any circular object in our life. So learning the properties of circles is very much useful for us to design any circular object. Therefore, it is very much necessary for us to know about circles. So first of all, let us know how to draw circle and how to define circle. Drawing circle and defining the circle. These are very important. Once you draw, you will be able to define. The method of drawing circle is very easy. Everyone know it. Though we do not know properly how to define it, it is very easy to draw the circle. We take one fixed center and a specific radius of our choice. Then we use this tool called compass, which is in your instrument box. Then move the compass like this. First we draw an arc, a small arc we draw first, like this. And this arc we complete later. We make it a complete arc like this. When you complete this arc, it becomes a circle. So here we have noticed three things important, 3 points. One is the fixed point, specific radius, drawing an arc, and completing the arc, and closing the arc. It's called a closed arc. Instead of drawing a part of the arc like this, if you draw only this much, it becomes a part of an arc. This is a partial arc. If you close this arc, if you complete this arc to form a circular figure, that will be called as a circle. So circle is drawn with a specific center, specific radius on one plane and completing it to form a circle. So that is how we define. Therefore, we should know how to define the circle. The definition of circle is, it is written like this. Circle is a closed arc. You can note this point. It's a closed arc drawn from a fixed center fixed radius on a plane. So this is the definition of simple definition of circle. There are many other definitions. Like if you consider this path, where the arc is completed. It is a curved path. Suppose you consider the one moving point here, say a moving point P and a fixed point as center. If this moving point moves from the fixed point always at equal distances from this fixed point, then the path traced out by the moving point is called as a circle. So circle can also be defined as the path, that is the curved path, traced out by a moving point such that it always moves at a fixed distance from a fixed point. So it can also, the path can be mathematically, the word path is, the separate word is used, it is called as locus. So locus is the path. Path of a moving point moving at equal distance from a fixed point. So that is also called as circle. So locus of a moving point such that it is always at equal distance from a fixed point, drawn on a plane or covered by the moving point on a plane, is also circle. So like this, we can define circle in many ways. Now we will learn the other properties of circles, so that, and we will also know later how they are useful in our daily life. The first thing you should know is the length of the curved path of the circle. Length of the curved path of the circle, we call it as circumference. Circumference. So it is represented by C and calculated by a formula 2 pi r. I'll let you know what is r and what is pi. R is nothing but the distance between the center and this is the center, if you represent it center point as O, and this is as the circumference. Take any point on the circumference, join it to the center. This distance will be called as radius, which is always the same. It does not change. The circle has same radius throughout the path of the circle, curved path of the circle, because the distance does not change. The radius, r is called the radius. Pi value is fixed, is a constant value. It is calculated as 22/7. So, circle C is the circumference of the circle, calculated by the formula 2 pi r. What is the speciality of this circumference? To know that, you can take a circular wheel, mark a point on it, and make the wheel move on the earth, surface of the earth, and so that it is coming back to its original point. Suppose I call this point as A. Keep this point A on the surface of the earth, make it move one rotation till it comes back to the original point, original position. Then you will see, then measure the distance traveled by the wheel in one rotation, one full revolution. You will see that it will be equal to the length of the curved path, that is the circumference of the wheel. Therefore, this is what is useful in designing wheels. So the circumference of the wheel decides the distance moved by the wheel in one rotation. So this is a very important point, useful. Now, why we attach more important to circular wheels? That I should have told you. I have not told you that. That is because the circle, whenever it lies on any plane, it touches that plane at only one point. If you keep the circular object or any circular wheel or anything on any surface, plane surface, it touches that plane at only one point. That means the surface will have a contact with the circle only at one point, and the opposition or the frictional force against the motion of the wheel will be the least. That's why you find the circular wheels being used in this trains, bikes, then buses, cars, all movable materials. They use these circular wheels. So that is how you feel that circle, knowing about circle is very, very important. Now, the first we have learned now what is R. R means the radius, circle, distance between center and the circumference of circle, and circumference is the curved length of the curved path of the circle. And then, suppose I draw a line passing through the center of the circle. Like this. If you draw a line passing through the center of the circle and touching the circumference at 2 points, say call these 2 points as A, B, then this line you can see very clearly, it divides the circle into 2 equal parts. That is 2 half circles. For each circle, each half part is called as a semicircle. Semi means half. So now we can define this line. What is this line AB? Touching the circumference at 2 points, passing through the center of the circle, and dividing the circle into 2 equal parts, or creating 2 semicircles is diameter. So this line is called as diameter. And you can easily measure the radial length of the radius of the circle and also diameter of the circle. If you measure it, you will see that the diameter will be double the radius. So you can also define diameter as a line which is double the radius of the circle. So you can give a relationship between diameter and radius. If you represent diameter as D and radius as R, then D, and if you have to put 2 times radius, that is D will be equal to 2R. So this is the relationship between diameter and radius. R, you can also say R equals half of diameter, D by 2. So this is the relationship between diameter and radius. Next, if you draw other than this diameter, suppose I draw any line, simply joining any 2 points on the circumference, like this. Then this line, it touches 2 points on circumference and it is joined. Now here you can see that this line divides the circle into 2 unequal parts. One part will be bigger and the other part will be small. So this line is not diameter, it is called as chord. Diameter will pass through the center, but chord does not pass through the center. Chord makes 2 unequal parts. Diameter makes 2 equal parts. These are and diameter can be also defined as a chord only under one aspect, thinking that it joins 2 points on the circumference of the circle. So we can say diameter as the biggest chord. So we can define diameter in many ways. Suppose I ask you to draw the bisector of one chord. You can draw many chords in the circle. Like this, one more chord here. You can draw the bisector of this chord. If you draw the perpendicular bisector of the chord, you will see that this bisector always passes through the center. You can verify it if you want. If you take this chord, it passes through the center of the circle. You have to draw the bisector to draw the bisector, what you have to do is you have to take more than half radius when drawing one arc. This is all, I think you know it. One arc other side and cutting the previous arc, and you will be joining the line. So these cutting points, we join them, you will see the bisector will pass through the center of the circle. Suppose you draw the bisector of this chord also, you can also see that also passes through the center of the circle. Draw another chord like this, anywhere, and draw the bisector of this chord. This chord also will pass through, the bisector of this chord will also pass through like this. If you draw two arcs and join this, you will see it will pass through the center of the circle. That means, what happens to the perpendicular bisector of the chords? Where do they meet? If I ask you a question, you can easily say the perpendicular bisectors of chords meet at one point, that is center. Earlier you have defined center of the circle as a fixed point. Now we can define center of circle in a different way using the property of perpendicular bisectors of chord. So center is a point where the perpendicular bisectors of chords meet, or center is a point of intersection of perpendicular bisectors of chords. Depending upon the property of chords, we can define the center of the circle also. So center of circle can be easily defined as the point of intersection of perpendicular bisectors of chords. And the other way also you can define chord. See, now you know that this is an arc. Whenever you draw a chord, there is an arc behind the chord. And the ends of the arc, when you join the ends of the arc, that becomes a chord. So, the line joining the ends of an arc of a circle, the line joining the ends of arc of a circle can also be defined as a chord. So chord can be defined in two ways. Line joining two points on the circumference, simplest. Second definition, line joining the end points of this arc. The biggest chord is diameter. Chord makes two unequal parts. Diameter makes two equal parts. The equal parts of diameter of a circle is called as semicircle. Radius is half the diameter and diameter is double the radius. Radius is the distance between the center of the circle and the circumference of the circle. Circumference is the length of the curved path of the circle, which is equal to the distance travelled by a wheel, circular wheel, in one rotation. Circumference is calculated by the formula C equals 2 pi r. Diameter can be calculated by the formula D equals 2r. Radius can be calculated by the formula R equals half D or D by 2. The center of a circle, suppose we know the length of a chord of a circle, then its center is not known, say, then easily you can locate the center by drawing any two chords and drawing their perpendicular bisectors. The easiest way is to draw two chords and drawing their the perpendicular bisectors. Suppose there is a triangle, say, triangle, usually everyone know it. Suppose you want to draw a circle around the vertices of the triangle. Then we can treat each side of the triangle as one chord and draw the bisectors, perpendicular bisectors. We'll get one bisector. Again, draw perpendicular bisector of the second side of the triangle. You will get like this. Then join these bisectors. They will meet at point. That becomes the center. So if you are given a triangle, you can draw a circle through the vertices of the triangle, treating each side of the triangle as a chord and drawing the bisector of the chord. We can locate a point where the bisectors meet. The perpendicular, if you treat the sides of the triangle as chord, then their bisectors will become center of the circle, as we have defined. The perpendicular bisectors of chord meet at a point called center. Therefore, draw the bisectors easily. Produce them to meet at a point. That becomes the center of the circle. Then that will be called as circumcenter. Because the circle which we are going to draw circumscribe the vertices, circumscribe the triangle, and it passes through all the vertices like this. So here we are learning two things. One is how to draw a circle around a triangle, around the vertices of a triangle, by knowing the properties of chords of a circle. Suppose we want to take out a triangular shape from a circular disc. The same thing we adopt. The same procedure we can adopt. Drawing each bisector of each triangular piece and locating the central point. Then cutting the piece, making a circular piece. So these are all the usefulness of learning about chord, diameter, radius, circumference, and other things. Now, say we have a circle and we have an external center and external point. Then you can draw a line from the external point to touch the circle at one point, like this. Say this is the external point. This touching line which touches the circle at one point, that is the circumference of the circle at one point, will be called as tangent. Like this, you can, if you try, you can draw two tangents from the same point. So tangent is a line drawn from the external point, touching the circle at one point. Like this, if you have an external point, you can draw two tangents. And if you measure the length of the tangents, they will be equal. So this helps you to make so many conclusions. The tangents drawn from an external point to a circle are equal. And if you locate the contact point of the tangent, suppose I call this as B and C, where the tangent touches the circle. Join these points to the center of the circle. You will see that it becomes a radius drawn from the contact point. Then the angle between the radius and the tangent contact point will be 90 degrees. So this makes us to conclude that the radius drawn from the contact point of tangent will be perpendicular to tangent. See, this property of tangents you can see in railway wheels, where the wheel is made to rotate with the help of a tangential force using a lever-like structure. So the wheels are rotated, applying force on tangential points. These are all the things which you will learn later, and usefulness of tangents and tangential properties. So now we have learned so many points. I like to give many questions for you. Please not all fill in the blanks like one word answer. Please try to fill in the blanks and learn. Other things on circles we will learn in our next class. Thank you all.